a Portland Community College mathematics telecourse. A course in arithmetic review, produced at Portland Community College. This lesson is a short extension of the last one, and it's just to help us to sharpen our feeling for the place value of each of those decimal places. And to do this, we will develop a form called expanded form, just as we did with whole numbers in Chapter 1. And it's just this simple. Take each place digit as a numerator and ask what's the value of its place, and that's first place is a 10th place. Then an, which in this case is plus, the next digit, which is the next numerator, and its place value is 10th hundredth, so we place that on the bottom. And the next numerator, and its place value is 10th hundredth thousandth, and 4 10th hundredth thousandths 10 thousandths, or as you can see in each additional place to the right, I get one more zero on that power of 10. So as it turns out, the digits are the numerators, and the place value is the denominator. And that's really all this lesson is about. So let's try another one. This says I have 2 hundredths, and this says I have no tenths, and I have 8 ones. Then and, that's still plus, I have 6 tenths. Then I have no hundredths, and then no thousandths, and then 5 10,000ths. And these no positions, sometimes we don't bother writing them, but sometimes we do, just to emphasize that those places are there, there's just no digit there. Just as here, this no tenth will sometimes be written as just that, no tenth. Okay, this form we call the expanded form. It helps us to focus on the nature of this number system and lets us see that each digit, by sitting in a different place, changes its value. So there's a digit value and a place value, which together form the total number value. Now to reverse that, if we were to write the place value name for this, place value means I want to write this thing in places, that's the place part, instead of fractions. So we remember that the first place is tenth, and we have 8 tenths. The next place is hundredth, and we have 2 of them. And the next place is thousandth, and we have 3 of them. Now, by not specifying those 0 places in this form here, the expanded form, it can be confusing when you're going backwards. Since that came first, there's a tendency to write it first. But this doesn't say 3 tenths, which is what this position is. It says 3 hundredths, which is what the next position is. There aren't any tenths, so we need to say that. And we say it with a 0, so we call this a placeholder 0. Now the next place is a thousandths place, but we don't have any thousands, so we need a placeholder there. The next spot is the 10,000ths place, and there are 5 of them. And the next place is the 100,000th place, and there are 6 of those. So we have consistently been calling these zeros placeholder zeros, and without them the number takes on an entirely different meaning. So let's concentrate on the nature of those zeros for a moment and their places. Now, which of these zeros are really necessary to preserve the value, and which ones are there perhaps for looks that do not really contribute to the value? Well, you can determine that if you begin to think of the place value. This says no ones, and of course if I don't have it, obviously there's no ones either. But if I didn't have that one, then there'd be a tendency to think that is 600th instead of 1000th. So that is a necessary zero. But this says I have 6 thousandths, but no 10 thousandths, no 100 thousandths. But for that matter, you have none of anything else that would have followed either. So as it turns out, these two, or this one, is the only one that's really necessary. That if these weren't there, and we had this instead, it would be the same number. Now let's incorporate that into a rule, because many beginners get confused on this point and will leave a zero out that's absolutely essential. Let's make this rather obvious but very important note. Behind the decimal point and to the right of the last digit, zeros can be appended or dropped without changing the value. Let's say we have a number like this. Now again, those zeros are necessary to preserve the place valueness of it. But behind the decimal point, on the end, I can append zeros or take them off at whim. That's strictly for cosmetics. It adds nothing to the value of the number. Except when we get to round off at a later point in this chapter, these decimals will tell me something above and beyond the actual value. But at this point, they're not really necessary. Now here's another zero that's used very frequently in business that has no value as far as numberness is concerned, but does help us visually and psychologically. This zero is not necessary, but you find in most business ledgers, billings from computer printouts will have that zero and sometimes one other here. Now the reason for that is purely psychological. Many people, when they write a decimal, will write very fast and somewhat sloppy. And sometimes you don't really see that. Or sometimes they'll write a decimal this way, and you're not sure whether that's a decimal or a zero. It would be nice if we could all be very emphatic like this, but usually we're in a rush and we don't. So, it has been found by many business people that if we put a zero in front and take that trouble, then we are more apt to notice the legitimate decimal point. So this is purely for visual and psychological help, but logically is not necessary. Watch this on the billings you get from the next mail out from the light or water company. Let's play with that idea for a few moments until you become quite comfortable with it. Here you have a decimal number, and our question is, which of these zeros are really not necessary for the value? Now, if I were to throw this one away, we would know that there is no units with or without the zero. So I really don't need this, but we've agreed that we will keep it for cosmetic purposes to help us really see this. But now if I were to leave this zero out, we would think that this is 5/10 because 10th is a first place value. But this tells me there are no tenths and 500ths. So this one is necessary. To throw it away would be to change the total value of our decimal number. And do you see that it's the same thing here? I need that. This one tells me I have no, can you name this place value? Let's see, tenth, hundredth, thousandths, 10,000ths, 100,000ths. So this says I have no 100,000ths. But for that matter, I have no millions, no 10 millions, no 100 millions, and so on forever. So these end zeros behind the decimal point on the end are really not necessary, except, as we mentioned, when we get to round off, they might tell us something about the number more than the value. But as far as the value is concerned, they're really not necessary. They're there for some visual purpose that's helping you to see something else. And you'll see cases of that in a few lessons. Once more with a different number. Which of these are necessary and which ones unnecessary? Now here again, this tells me that I have no, say, units, tens, hundreds, thousands. I have no thousands. This says I have no 10,000s. But for that matter, I have no 100,000s, millions, 10 millions, and so on forever towards the front. So as it turns out, these zeros at the front end of whole numbers are not necessary. By the way, if we have them there, they're not wrong either. They're just not value-wise necessary. But notice it's the same towards the end. This is tenth, hundredth, thousands, 10,000s, 100,000s, and this one says that I have no millions, no 10 millions, but for that matter, I have no 100 millions, no billions, and so on in this direction. So all of these decimal zeros on the end behind the decimal point are not necessary either. So you know we have sort of a rule between decimals and whole numbers together now. The zeros at the end behind the decimal point are not necessary. Zeros at the front, in front of the decimal point, are not necessary. But all other, and we could call them in-between zeros, are very, very necessary. If I didn't state these two, I would read this as 3/10, no 100s and 3,000s, where this is to be 3,000s and this is to be 500,000s. So in-between zeros are very, very critical. To not put them in changes the value. The end zeros, the end of decimals, in the front of whole numbers are not necessary. Do you recall a similar problem like this from your whole number division days? Do you remember this problem from not too many lessons ago? Let's begin to do this problem once again together and see a relationship between this problem and the point we're discussing about necessary and unnecessary zero. First, realize this zero is necessary since this is a whole number, because to leave that off would be to say I have the number 697 as opposed to the number 6,970. Just think about money. That's a lot more money than that. That zero is very, very essential. Now notice it's not an n zero. We said n zeros are not necessary behind the decimal point. And that zero is not behind the decimal point. So it is necessary. So we will see that this divisor goes into this one approximately twice. Multiplying gives me 68. Subtracting gives me 1. Bring down my next place number. And you recall some lessons ago, there were some people that would say this does not go into this. So then they would say, bring down the next number, and this does go into here, looks like 5 times. And then they would say 5 times 4 is 20 carry the 2, 5 threes is 15, 17. Then say, okay, I'm done. This goes into here 25 times. But if you took 34 times 25 to check it, and until you're very secure, you should always check it, watch what happens. 5 fours is 20, carry the 2, 15, 16, 17. 2 fours is 8, 2 threes is 6, 0, 5, 8, and this is anything but that number. So there must be something wrong with this. And what happened was when we brought down this 7, it was improper to say that 34 will not go into 17. 34 will go into 17 0 times. Now notice up here, some people would say, well, 34 does not go into 6, so we bring down the next one, which is 9. But in fact, 34 will go into 6. It will go in 0 times. But the reason that we traditionally don't write this 0 is because on the whole number, it's at the front end and hence not necessary. Knowing that ahead of time, we just don't bother writing it. But in between zeros, as you should become very conscious of in this lesson, is absolutely necessary. Now, if we were to take 205 times 34 and multiply that, and I won't do it here to save time, I've already done it on the calculator, and the answer is this. And it does check. So, once again, let's finally become very, very conscious of this should be obvious fact. And that is simply this. When you're writing a number, whole number or decimal, or combinations of the two, in between zeros are always very, very necessary. These are what we've been calling placeholder zeros. But at the behind the decimal point on the end, zeros there are not necessary. If you have them, you can throw them away. Or if for some reason, and we'll have reason in the future in many cases, you want them, that's okay. Just stick them in. They will not change the value. If you stick them in between, it will change the value. So behind the decimal point on the end, zeros are not necessary, however not harmful to the value of a decimal number. With a whole number, in between decimals zeros are just as important, whether they are here or at the units place. But zeros at the front of whole numbers are not necessary. And as we pointed out, there are times, however, when we traditionally will write a 0 in front of the decimal point, even though technically it's not necessary, just to emphasize and force us to really see the decimal point. Now, it may sound like I'm sort of beating that point to death, but the only reason I do it is that for beginners or people that need heavy review, that is a common mistake, to throw away zeros that are very necessary and to not know when they can put in additional zeros which will not change the value even though the looks are changed. So it is an important point that is commonly misunderstood. While we have this number before us, let's do a bit of reviewing. What's the word name for this place value named number? First, look at the whole number part and say that by itself. So that's the number 201. Remember, we don't say and, 201. There, that portion is the word name for that portion. Now, the word name for the decimal point is the word and. And to say the decimal number, we pretend like the decimal point and the whole number isn't there and read this as though it were a whole number. And of course, if it were a whole number, that 0 is not necessary. So we would say 507. But if we were to quit here, 201 is this, and 507 is this, and this statement is simply telling me that I have two numbers, perhaps not even being added, just two numbers, this number and another number. So somehow we need the word that will let me know that this is a fraction. In fact, it's the numerator of a fraction. So now we have to say the denominator. So we have to give the word name for this end place. So this is tenth, hundredth, thousandths, 10,000ths. So 507 10,000ths. And please note, we need the dash, otherwise we think we have 10,000ths, which is different than the single place 10,000th. And it's the TH that tells me we're in the fractional position. Very subtle. And it was very clever of our ancestors to invent this rather simple system of place value names that allows us to write an infinite variety of numbers with a very small finite set of words. Now, let's use the same number to explore another aspect of our growing vocabulary. What do we mean by the expanded form? Well, this is a vehicle by which we are able to tell what happens to each digit because it's in a separate place. If this 5 were here, it'd be 5 tenths. If it were here, it's 5 hundredths. If the same 5 were written here, it would be 5 thousandths. So where you write a digit changes its value. So this 2 says that I have 2 hundredths. This 0 is a placeholder that says, in addition, I have no tens. And this says that I have 1 ones. And this says I have no tenths, and this one that I have 5 100ths, and this that I have no 1,000ths, and this one that I have 7 10,000ths. And sometimes we will shortcut this by simply saying I have 2 100, a 1, 5 hundredths, and 7 10,000ths. Usually when you need this expanded form of a number, particularly in math for elementary teachers, this form would be negated in favor of this so that we can see that every place, every single place from the beginning to end has been accounted for. Now let's do the reverse. Let's say we have a number written in that shortened, expanded form, and we want to go back to the place value form. Well, let's start with a decimal point. Going this way, I have my units, and I have 7 units. Then I have tenths, but I have no tenths, so I need a placeholder 0. Then I want to know how many hundredths I have. I have 3 hundredths. That should be very obvious from 2 chapters ago. But this says 5 1,000ths. Therefore, to put a 5 here would be an error. This is the number of tenths. Therefore, I have no tenths up here. But to put the 5 here would still be an error because this is my hundredths place, and I have no hundredths here. So again, I need my placeholder 0. This is my thousandths place, and I have 5 of those. And this is my 10,000ths place, and I have 9 of those. So this is my place value name for this, and the word name would be 307 and 59 10,000ths. Do you see how that's done again? We read this, and then it's place value, and that gives me the number value. You should be very, very comfortable with this following a successful completion of this lesson. Let's use this to recall another idea from the last chapter, which we'll be called upon to use in the future. This in expanded form tells me I have 5 tenths. Then I have 2 100ths. Then I have 3 1,000ths. And then I have 4 10,000ths. And then I have 8 100,000ths. Recall from the last chapter that we could write each of these powers of 10 in exponent notation. This is simply 10, which we said 10 to the first power. This is 10 squared, or 10 to the second power. This is 10 to the third power, or 10 cubed. This is 10 to the fourth power, and this is 10 to the fifth power. And recall, when these are powers of 10 greater than 1, that these exponents in effect count the number of zeros following a 1. So 10 to the fifth is 1 followed by 5 zeros, 10 to the fourth is 1 followed by 4 zeros, and so on. Sometimes when we write this in expanded notation, you will do it in using this kind of notation. You'll say 5 tenths plus 2 10 squared plus 3 10 cubes plus 4 10 fourths plus 8 over 10 to the fifth. In more advanced math, you will find that this will become a more convenient notation than this. So once in a while, think back on what we've covered in previous chapters, because we will very soon begin to tie them together into one subject matter. So once again, the main purpose of this particular lesson is to go from a decimal notation to expanded form and back again. Do become very comfortable in that process. Until the next lesson, this is your host, Bob Fennell. Good luck.